G'day guys, how you going? Welcome to another video in our video series. We're back on physics today and we're actually going to be looking at radioactive decay. So just like a piece of fruit that can decay, what you can have is atomic nuclei can actually decay as well. Okay, so just like this apple just here decaying, all right, an atom can decay and it can decay in three different ways: alpha, beta, and gamma. And we're going to be looking at those three different ways and kind of summarizing them the best I can today. So alpha decay is when an unstable nuclei decays to release an alpha particle. And an alpha particle is this just here. It is 2 protons and 2 neutrons, okay? When you're in doubt, think alpha equals top, like an alpha predator is a top predator. So an alpha particle is big. It's the largest of the three. And it is made up of 2 protons and 2 neutrons, okay? If it's made up of 2 protons and 2 neutrons, it's the same as a helium nuclei, right? Because 2 protons is helium, hydrogen is 1, helium is 2. And so you've got the same as a helium nuclei. So you could see it represented as atomic number of 2, mass of 4, helium, or you could see atomic number 2, alpha symbol, and then a mass of 4. It could be represented in either of those two ways, but that's what it is: 2 protons and 2 neutrons, okay? So when an alpha particle is lost, when it breaks off from your nucleus, you're going to lose 2 protons and an atomic mass of 4, because you're going to have those 2 neutrons as well. So when an alpha particle is lost, you lose -2 to the atomic number, so 88 will go to 86, which means the element will change, and that's really important, okay? And your mass would move from, you would lose 4 to mass as well, because the 2 protons weigh 2, the 2 neutrons weigh 2, total up, that's 4, okay? And so you would lose 2 to atomic number and 4 to atomic mass, as you can see in these equations just here. As a tip, if you get an equation like this, which can happen, make sure the right adds up to the left. So 226 is 222 plus 4, 88 is 86 plus 2, right? And so you can use that as a bit of a cheat. All right, so beta decay is when a neutron becomes a proton in a nucleus and then an electron is shot out or released. And so what you have is beta means smaller, right? If it's a beta predator, it's a smaller predator or something like that. So the electron that is released is much smaller. So think beta means smaller, which means you're only going to be releasing an electron when a neutron becomes a proton. So what happens is beta particles are just an electron. They have no mass, as you can see from this top one, but they have a charge of -1. So you can see this -1 just there, okay? And that's how they'll be represented in your papers. So when a beta particle is lost, because that neutron has become a proton, what that means is you get a +1 to atomic number. And so you can see the atomic number here has gone from 6 to 7, which means you get a change in the element. The carbon becomes nitrogen. All right. However, this atomic mass stays the same because neutrons and protons weigh the same amount. Okay. And you also get a beta particle, or the electron, released from the actual decay. Okay, and that's beta. So lucky last is gamma. Now you don't need to know as much as you do about alpha and beta as you do about gamma, but I'll do the best I can. So gamma decay is when a short wavelength of electromagnetic radiation is released. Okay, and so this basically means that this decay of this nuclei causes this photon or this electromagnetic radiation to be released in the form of a wavelength. Okay, so it's an electromagnetic wave, and you can see it here. And this symbol here, that kind of funny looking V, is the gamma symbol. And so when gamma radiation is emitted, and this is probably the easiest part about it, there's no change in charge or mass. It is exactly the same all the way through, because there's no protons and there's no neutrons in the particle. It's just a photon. It's just a wavelength of energy. Okay. All right, lucky last. So you need to know about these three and how they can sort of penetrate or absorb into substances. So because alpha particles are quite large, literally a piece of paper would block them, right? Because they would hit it being so large and they would just get absorbed. But because they're so large, think of them as almost quite large, and then bam, they're going to cause a bit of damage when they hit. So alpha particles don't penetrate far, but they're really ionizing, okay? Beta particles, those electrons which are a bit smaller, will penetrate through objects, all right? However, they will get stopped by something like a piece of aluminium foil would stop a beta particle. Gamma rays, being the smallest of the bunch, can actually penetrate quite far into objects. So they can penetrate through things like aluminium, but will be stopped by something like a thick piece of lead. So alpha particles penetrate the least, but they are the most ionizing. Gamma particles penetrate the most, but they are the least ionizing there. All right, hope this helped, guys, and I'll catch you later.